Right, so this will just be one that shouldn't take too long. It might take you a couple of times to watch through it, to be honest. It's proving trigonometric identities. It can be quite tricky. There was kind of the start of this in National 5, and we're expanding on it a lot in higher, and there's a lot more into proofs in advanced higher as well. So, what we're going to have is we're going to have a question that says something like, prove that sine of x plus pi over 6 is equal to a half, and then in brackets cos of x plus the square root of 3 sine x. Okay, so it looks like the question is going to be given to you, and they've given you everything you need to know. You need to start from one and get to the other. So the way to lay these out, and remember, you should always kind of try and emulate my working if you can. Like the way I lay it out is the way I want you to lay it out. So first thing we do is we look at the left hand side. So we pick one side of our equation that we know that we can kind of work with, we know we can expand. On this side we've got sine of x plus pi over 6. That's a compound angle, so we know we can expand that, and then from there we can simplify, and this is where we're headed. So that's giving us that kind of place that we know we have to get to. So if we've not got a square root of 3, we've not got kind of halves and things, we know we've gone wrong, and that's like it's leading us to where we want to go. So we look at the left hand side. So we've got the sine of x plus pi over 6. So compound angle, we know that we've got sine of x cos of pi over 6, and that's going to be plus cos of x sine of pi over 6. So we now need to know what the cos and the sine of pi over 6 is. Pi over 6 is the same as 30 degrees, so we've got this little triangle here, pi over 6, and it's 1 to root 3. So we get that cos of pi over 6 is equal to, cos is adjacent over hypotenuse, so that's root 3 over 2. So you can see already we've got root 3. We're getting there. We've got root 3, so we know we're kind of along the right lines. And then we've got sine of pi over 6, which is going to be 1 over 2, so a half. Oh, look, we've got a half as well, so we're getting there. So then we've got sine of x is just sine of x, cos of x is a number, not cos of x, cos of pi over 6, which is root 3 over 2, so we get root 3 over 2, and we have sine x. And then on the next one we've got sine of pi over 6, which is a half, and then we've got the cos of x. Okay, so we're kind of almost there. This one's not actually taking too long, so all we've got to do now is take out a factor of a half. So we take a factor of a half out of root 3 over 2, you just get left with root 3 sine x, and if you take the factor of a half out there, you just get cos x on its own, and then we can just kind of rearrange it a little bit to get it how it's given in the question. And then we've proven it, so we can say that equals the right hand side. So therefore, proven, or QED is the other one. So you can just write like QED at the end, which means I've proven that this is correct. And but you have to state that they're equal at the end, okay? Right, so what I'm going to do for this one is I'm going to do a more complicated one as our second example, and that's all the examples we're going to do for this one. Is I'm going to do cos of 3x equals 4 cos cubed x minus 3 cos x. Okay, so this is prove that. So we always look at the left hand side. So we've got cos of 3x. So this is kind of combining everything we've done so far all into kind of one question, one proof question. Can kind of combines everything we've done. So we know that cos 3x, we can write that as cos of 2x plus x. So then cos 2x, we can use our compound angle formula to write that out as cos 2x cos x, take away sine of 2x times by the sine of x. So now we need to put in our cos of 2x. Okay, so our answer, this is where choosing which is going to be the correct one to use here. So we've got cos 2x, what we're heading for has no signs in it at all. So we want to get rid of any signs that we've got in here. So we're not going to pick cos squared minus sine squared. We're going to pick the value for cos 2x that only contains cos. So that is 2 cos squared x minus 1, and then that's still times by cos x, and then we've got to take away sine 2x goes to 2 sine x cos x times by sine x. Okay, so it is getting a bit more complicated pretty quickly. Right, so over here we can do some multiplying out. So we're going to get 2 cos cubed x when we do our first bracket there. I'm going to have to take away cos x. And then over here, once we kind of combine it together, we've got 2 sines, so we're going to take away 2 sine squared x times by cos x. Okay, so just as a wee reminder over here, what we've used is we've used that cos 2x is equal to 2 cos squared x minus 1, and we've used that sine 2x equals 2 sine x cos x. Okay, so now we want to get rid of the sine squared x in here. So this is using another one that we know. So we know that sine squared x plus cos squared x is equal to 1. So then we know that sine squared x is equal to 1 take away cos squared x. So we substitute that in, we get 2 cos cubed x minus cos x, take away 2, and then in brackets we've got 1 minus cos squared x times by cos x. So again, this bit just keeps being copied down one line to the next, and then we're going to have take away 2, and then in brackets times cos x minus cos squared x, so this is me multiplying out this bracket here. So then we're going to get minus cos cubed x, and then again, still going, 2 cos cubed x minus cos x, and then multiplying out this bracket this time, so minus 2 times cos x is minus 2 cos x, and then minus 2 times minus cos cubed x, so it's plus 2 cos cubed x. So then we've got 2 cos cubed x and 2 cos cubed x, so we've got 4 cos cubed x, and then we've got cos x, take away 2 cos x, take away 3 cos x. There we go, equals the right hand side. We've got there eventually. It's taken a wee bit longer, it's a wee bit more complicated, and there's a few more steps, but all of it is stuff we already know. It's just manipulating our expressions and getting them where we need to be.